Hello everyone, you know the drill here. We're gonna do a Leetcode question. One of the questions for today is container in most water. So let's see how this can be done. This is a nice visual here. All you have to do is try to contain as much water as you can in between these bars. And the array represents the bars. It's so the first instinct is to every possible combinations of bars, two pairs of bars, which is just like a for loop inside a for loop, right? And see it, but that's not gonna work because there's 30,000 possible bars here in the array, and if you do that 30,000 squared, that's what is that, 90 million 99 billion something around that. 30,000 squared, yeah, so how many zeros is that? 900 million. So that's going to be 900 million. So you don't want to do n squared solution, so you want to do something less than that, which is n log n or n. But I think we can do this in linear time. If you just, the idea here is if you just like keep shrinking. So if you see a smaller, so you start off with the widest one. If you see a smaller one, you increment that, right? So then there's that. In this case, this is the maximum, but let's say you haven't explored yet. This is smaller, so you go increment, decrement this to here. This is smaller, you decrement this. These two are the same size, so that when two things are the same size, you might want to consider, you don't want to just pick a random one. You actually want to increment both this and then decrement this, because that you might miss. Let's say if you just decrement this, then you're missing the possibility of getting these two. So you don't want to miss that. And the same thing here. If you, let's say you increment this, and you have these two, then you're missing the possibility of these two. Right, and you want to consider all possibilities. So here's how I would implement that. J equals length height. Those are the two ends. While I is less than j, then if height of I is less than height of j, then I increment I. Else, or L if height equals to j, then you increment the I and you decrement j. Otherwise, you decrement j, because that's the other side. And in the meantime, while you're doing that, you're keeping track of the maximum. Let's see, how would you get the maximum? So the maximum is length times width. So the length is j minus I times, length. The width is j minus I, and the length is the smaller of the two. So I'm just gonna say min height of j, height of I. And then we should have seen every single possible combinations of heights that would give you a return. And then we would have collected the biggest one. So this would be a linear time solution because you're only shrinking, and you're not repeating any values or any heights or any areas. So let's see if this works. Yep. Let's see if this works. Yep. So yeah, this isn't too bad of a problem. So hopefully you learn something from it next time.